The strength of today can know from you please. Is a audible or not also? Guys, was it audible for you? Can someone please raise your hand? Oh, fine. Again, yes. Hey guys, as we discussed about the manufacturing and the ABS session, right? So let me repeat it as normally. Okay. So the manufacturing is all about it is in the creation of a services of a goods and etc. thing, where it based upon a two main things, which was human labor and the machine utilization. And like after of later things, it has been implemented only in the digital technologies way. So, like as you know, the communication skills how used to be in earlier years, like so the page and etc. In that way, they used to be inbuilt like that. And the next thing was the current top the trends of these manufacturing are like so the top things of these manufacturing trends were the IoT sensors and devices which is connected to be a network. It collects the valuable net data to simplify and like yeah. Whatever the coming to the IoT itself, it says that how the devices have been really connected and to the network, which it collects the valuable data to simplify and improve the industrial activities. So yeah, for these IoT sensors and the devices, which it could be connect to a network. The basic working of an IoT itself, it is often a connecting often in between two devices a network, and it transmits the data and auto also receives the data in the same way. It whatever it collects the data here, it simplifies it and it improves the industrial activities also. And the next thing was like while implementation of an IoT itself, they took a consideration of which two things to be a working status, which is in a artificial intelligence and the machine learning itself. So with these things, they have got up to some got up some algorithms with that they have analyzed the raw data to be transformed into the physical actions. And third thing was robotics. So these industrial robotics have been working for industries just like a human work. The human how they could do the work of an half of the 24/7 work. So the robotics can be get these work to be done often more of info by second. And compared to the other top digital trends, this is the most effective and costly thing. So highly cost effective thing. And the last thing was big data and industrial analytics. So these technologies are enabled for manufacturers with the three things, which is to be manage, update, and analyze. So with these three things, it increases the amount of digital content in between the product and in between the computer and product information. So while this cost and downtime, it decreases the cost and the downtime. The last thing was a big data and industrial analytics. So these technologies will be enabled that the manufacturing should be managed and to update and to analyze this increasing of an amount of an digital content. So in these two things gonna be considered in between the customer and the product. So with these, they're gonna decrease the time and the cost of a downtime. And this is all about of this, which is the current top trends of a digital, which is the IoT sensors and devices, which which like, it connects in between it connects in between the devices of a network, and with that it collects the valuable data to simplify and to improve the industrial activities only, and then and these IoT and sorry, these are two of one thing, which is an artificial intelligence and machine learning. Gonna have some advanced algorithms which it analyzes the raw data and it transforms into the practical actions even. And the next thing was robotics, which is in a highly cost effective, and it helps to be to create some essential of stages with the raw data to be final product. Like robotics, coming to the robotics, coming to the robotics. It's gonna be perform all the tasks from the raw material to the final product with of a 24/7 of that. And the last thing was big data and industrial analysis. So these things gonna be have some technical technologies of a way with the three things, which is a manage, update, analyze, increasing of amount of digital content and map customer and product information and decreasing systems cost and downtime even. And the next thing was those IoT manufacturing uses. So these are basically has a six things. These uses have a six uses of manufacturing IoT. Those were a remote production control, predictive maintenance, industrial system management, digital twins, logistic management, and manufacturing KPIs. Guys, was I'm audible for you? Can someone please raise your hand, respond this thing? Thank you so much. So, okay. The six things which it uses for the manufacturing process, these six things gonna be used with an application of IoT, which is a remote production control, predictive maintenance, industrial assistant management, digital twins, logistic management, and manufacturing KPIs. Coming to the first thing, remote production control. So remote production control is all about the configuration of the equipment and the monitoring of the monitoring of the whole processes. So these remote processes all the work of it is to do the monitoring and after the getting of the monitoring these whatever the process of an there from the start of the end of the business line, so it gonna to take off the all the equipment of a configuration, like all the cycle, whatever it has it done. So they're gonna see everything of an in detail way. The firstly, it is being so much implemented and so much productively happened to the employees that employees has been used to collect such kind of an information where while going off that production processes. So they have checked some specific outcomes, whether it's coming within a specific regulations and the requirements of whatever you have needed. Okay. And the second thing was they can be tune and configure these kind of a disease with remotely and significantly by saving of a time and effort. So firstly, it has been implemented the process of the data, which what was the process is that. So if you're doing the whole thing, was it really getting a specific regulations and requirements whatever you required? So well like that. So for that of a question, they have implemented such kind of an application where that saves the whole data by recording. So it's gonna say whether it is profitable or the regulations were and the requirements all has been happening according to the schedule or not. Okay. And second thing they have done this is because of a saving. Was it really the work? Was it really the work of having some kind of an effort? And does it saving the time and like yeah, if it doesn't get enough profit of a way, then like you're gonna waste your time and effort, right? So in that way, they're gonna configure the devices of an array. They're gonna configure it on devices and remotely, and moreover, remotely, and moreover, these automotive devices gonna allow the employees to be fix this many performance issues. So moreover, these automated devices gonna fix allow the many performance issues. Like yeah, coming to this point, it is all says about if emergency or any alert situation was being held upon there in that environment. So in that environment, if you got such kind of a situation to held within some kind of dangerous, so in that time that doesn't wait for any permissions or it doesn't wait for anything to be done or any situation going to get to be stopped. So it will be operated very automatically processes. So with that automation of a process, it is also is about with that automation of a processes, it's going to rectify the issues and it kind of fix the bugs and etc. things. And the next thing was the next thing was it is used for often a device location. So while if I'm monitoring this, the employee is going to be have aware of a device location by including some movable aspects, etc. And the next thing was with these sensors, this IoT industrial software going to have some remotely keeps the tracking of a power consumption throughout the production cycle. Production cycle. So yeah, for the last thing, it's gonna track the power consumption throughout the production cycle itself. So the last thing it says about the tracking of a power consumption. But one last was saying about the device location of a including the some mobile aspects it tracks of and aware of. So yeah, remote production control is all about the process of a remote monitoring and equipment configuration. So firstly, they have been implemented for an employee where to collect where to collect such kind of information on our production processes and to check whether these were coming really great output with to meet our specific regulations and requirements, whatever we required. And secondly, they have a come to a tune and configuration devices to remotely significant sum of a saving time and effort, etc. Moreover, these automated devices allow the employees to fix many performance issues. So yeah, coming to this thing of a remote production control, it is all about the process of monitoring and the configuration equipment of the whole, like just like a cycle of that one start to end of a production. So yeah, then later they come for this monitoring such collecting of an information and production processes and checking the outcomes the specific regulations and requirements. And secondly, they have been come to the tune of investing a significant of a saving time and effort. And whenever these automated devices has been any out any performance issues and etc., they're gonna fix immediately. Okay, let's go to the next thing. And the next thing is a predictive maintenance. Three. So the next thing was a predictive maintenance. So coming to the predictive maintenance in this, there will be no human to human interaction. Maybe we're gonna have some human to human to mission device interaction. So just like I have said in earlier, I have said in the first class, I think. IoT doesn't require any human to human interaction or a human to machine interaction. It was a process of it was a process of an automation, so like automatic processes. So yeah, the first point is all about like that only. And the second thing was it gonna have some embedded sensors. With that sensors in a machine, they want to detect some operational malfunctions. Like they're gonna detect if the weather, if the temperature was high or pressure was on high or voltage is on high. If it low or high, they're gonna alert us with some kind of application. And the third thing is mm, it alerts the equipment by leaving of an only like taking some remediation steps to the unemployed. It is most important. So by these processes, although discuss a debate two ways, which is a predictive maintenance and predictive repairing, it allows the technical services teams to be detect some issues before they result to be a serious equipment failure and after all fix them with the downtime. Long-term and cost. So these predictive maintenance are also always the integration of an IoT connected devices with some advanced of an elastics of software to anticipate when these technical support services needed. So basically, these predictive maintenance was integration of an IoT, which it connects the devices. So for now, it was also for now it was also implementing some of an advanced analytics of the software. So yeah, this predictive maintenance also allows the integration of an IoT connected device with advanced analytics software to anticipate when the technical support service is needed. So coming to the next thing, which it is business management. So the manufacturers has been these mainly concentrate upon the monitoring process of a real-time information of all their assets in the mobile or on a web or an applications. So in the web or a mobile or an application. So these tracks the assets which may include the three major things, which was on a vehicles delivering of a raw time or on a produced goods, or next thing was items in warehouses, which is shortly said to be inventory management. And the next thing was a resource during the production processes. So like that way, thus these we can they track this and they optimize the assets from all manufacturing stages from the supply chain to the end product delivery. So the proper asset management enables the quick and efficient identification of the issues that were advertisingly impacted the product quality or time to market. So they're gonna track and optimize the all assets of an all manufacturing of an stages from supply chain to the end product delivery. So the product asset monitoring enables the quick and efficient identification of issues where advertisingly impact the product quality or time to. So basically, these industry assist investment. So basically, these industry assist management gonna do the three major things, which is to optimize the optimizing and the monitoring of the real time information with an all assets with the come of a web or a mobile applications. So the three things which it mainly concentrates, which is vehicle delivering of a raw materials or produced goods or of items in warehouses or resources during the production processes. So like this, it tracks and it optimizes all the stages from the like supply chain to the end product delivery. So this is the asset of monitoring of enables which is a quick and just identification of an issue so that gonna advertisingly impact the product quality or a time to be a market. So it is all about the tracking of three things, which is like a goods and services, raw materials, items to be a warehouses, etc. Things all about tracking processes. And the next thing was digital twins. So coming to the digital twins, so it is often a some kind of a technology which is based is like of an Internet of Things, which is AL and ML, often a cloud computing, and cloud computing. So basically, these two have right now the platform, but later on they're gonna also implement some more of these technology. The first of the two things they have technology brought up with an machine learning and artificial intelligence. And also now it is the cloud computing has been like cloud computing also part of that from the starting itself, but now it's implemented in a huge way. These digital twins of now virtual copies of a physical objects are there. The application on manufacturing of a floor can be a more useful. So with these virtual copies of an equipment, they're gonna have the spare parts. So with these spare parts, engineers and managers gonna be build some kind of an experiments, and they're gonna they're gonna discover whatever the issues the really these things were facing with that spade parts, and they're gonna choose some kind of a results, like they're gonna test it, they're gonna make the process, and they're gonna get what was the really problem, and they're gonna choose what was the risky process and damaging things which been holding on their physical assets. So basically, with the virtual copies of the spare parts, they're gonna stimulate what was like they're gonna conduct experiments, and they're gonna discover issues, and they're gonna see what was the process of that, and what is making the damage, and what is making the risking, and etc. things. So the next point is all about it is digital twinning, which is gaining the popularity as much in a way. So yeah, this are all has been this technology basically has been implemented on the 2018, which it expected as up 30% of an improvement in a cycle times of a critical process event. And the last thing of this is by applying this IoT approach, like digital twins. So these businesses can allow that to be a create or robust the digital copies but to visual copies of an object, physical object. So these applications wanna have on a manufacturing floor be handy with virtual copies of equipment and to spare parts. So these managers gonna have then we have stimulate the processes and discover the issues. So these achieve the needed without risking or damaging of the physical assets. So in this way, the digital twins is all about is a kind of a technology which is based upon the three things, which is artificial intelligence and machine learning and the cloud computing. So these twins are virtually like by taking off on virtual copies of an physical objects, and their application on the manufacturing floor gonna get to be very useful. With these virtual copies and equipment of a spare parts, these managers and engineers gonna stimulate some numerous processes, which is like conducting of an experiment, and by discovering some of an issues, and what the to achieve the needed of results with risking and damaging of a risking or a damaging of a physical risking or a damaging of some kind of a physical assets. So, and then the third thing was sorry, and the third thing was that the digital billing is really gaining a popularity, which is also implemented in the 2018 this technology, and it has been becoming a very often advanced way right now. Just like all the IoT applications, it is also one of that of one highest advancing way. And by applying these IoT of approaches, so they're gonna create robust digital copies with the virtual copies of physical objects. So by their application, and by there with the kind of an application, shit. So by these applying of these IoT approach, these businesses want to create some digital copies also. So yeah, just like I've just mentioned you before, with this ritual of an equipment, these papers, they wanna inbuilt some processes and they discover the issues and they discover the new things without any bringing of without any bringing of a risking without any bringing of a risking or a damage or else a damage of a processes with glasses. Next thing was logistic management. Is logistic management. So these logistic coming to this logistic management, um, it is of like it is a risky process coming to the weather, okay, and it mainly has a huge impact upon the transportation. It has a mainly of a huge impact, huge impact upon manufacturing. Sorry, a huge impact of an attract, huge impact and impact of an impact of an transportation. So, like yeah, uh, fusion so, like, yeah, these depend that significantly on a transportation of an interconnection between the device and system. Okay, these is got to be considered, which it was in the transportation. It has been considered with of a interconnection in between the IoT lead of various devices and the systems. Okay, so devices and the system. Okay, and they want to deal with cargo tracking and the fleet management where it implemented from the warehouse. So where it is implemented from the warehouse. So we want to deal with more use cases also by typically the supply chain. So these technology going to be act a virtual role behind the digital transformation. Um, yeah, it is like previous days it has been implemented for more of a human to human of a transportation, etc. But right now it is everywhere. It is became the digital transformation itself. So yeah. So and then next thing is logistic managers gonna use this repair and fuel expenditures also. Okay. These logistic managers will also deal with IoT, deal with the use of repairs and fuel repairs and the fuel also different expenditures also, and they can be optimized to their tasks, which it covers monitoring fuel costs and smart deliveries and diagnostics on the drivers even. So so a real time look over a driver and a vehicle performance going to raises the technicians to be safety, which it brings down the inventory damage and the lessons of an insurance payments. So yeah, the safety is more important in the transportation. So these performances going to raise the technicians with the better safety and which it brings to be a down a very inventory open a damage in this is insurance of a payments. So basically, the logistic management is all about a transportation. So this going to be get to be a risky way when there was a lack of control over the weather. So these highly likelihood of like a fraud and etc. large number of aspects which it needed to be managed. These companies. So basically, these depend upon transportation, as I have mentioned before. So it has interconnection between various devices and the systems. So they gonna get to be deal with many use cases, many supply chain and warehouse of a fleet management and cargo tracking, etc. things. So it is a virtual force behind any digital transformation. So these logistic managers gonna use these IoT to be repair and fuel expenditures, which is very good thing. I need to optimize as a task over the covering of monitoring fuel costs and smart deliveries. You know the smart deliveries. If you're an online shopping keeper, then you want to know that what is a smart delivery means to be and it is same. So these real time overlook of a driver and a vehicle is performances of raised to a technicians safety and brings down that inventory damage and the lessons to be ensure the payments. So these logistic management is all about the transportation, which it got to be risk coming when it So it's gonna be get a risk with when the weather is not going to be controlled. And it deals like just like an example for cargo tracking and fleet management. Even it take care of the fuel and repairs of expenditures with itself. We're gonna use this task just more of like smart deliveries and drivers on etc. So it is all about the real-time processes of vehicle performance, which it is to be technicians with the safety and brings of a damage and insurance, wait, safety and brings of a damages of insurance of impairments. The last thing was manufacturing KPIs. So the last thing was manufacturing KPIs, which is a key performance indicator. Key performance indicator, it is a thing which it metrics that are giving critical insights to a business performance. So it is all about like it is all about a business performance of a verification, just like whether it is implementing in a great way or not, to understand what is the actual performance is really going and under some kind of a decision making things and etc. So let me explain what it was. So these important manufacturers has been became that very defined and manufactured to help the business focuses on to be what's most important. Plus, they're gonna track and analyze and it optimizes the performance over some time. They're gonna track or they wanna analyze or they wanna optimize the performance over every time. So one commonly used manufacturing KPIs is overall equipment is efficiency, which it shortlisted to be OEE, overall equipment efficiency. It is used to measure the calculating whether the factory of a performance is well or not, and the quality even also. So yeah, it is measured for calculating for factories performance on availability within a quality. So like this will be a more ideally used with a KPIs to KPIs for a KPIs for an better understand the performance from the diverse perspectives. So these business gonna choose several KPIs to help to help in the way to a guide of decision making. So by having these KPI dashboard, really it was available to even make the company's priorities to be stay focused and these ensure that the organization is moving on the right track or not. Okay, as I have just mentioned you before, it makes the thing which it is focused to be make the all the priorities to be get to be focused and to also ensure that the organization is moving to the right track. And the goal of these is to reduce the time and effort which it takes to understand the performance matches expectations or not. So ultimately, these industry IoT operations gonna corporation going to have some of an IoT platforms, which it was having which was having some platforms of analyzing over the completing and contextualizing even. So these work of this is to work of is this to it will make sure that that the monitoring has been implementing in a great way or not. The goal of it is to reduce the time and the effort which it takes to be understanding in a performance, which is matching our expectations or not. So, so ultimately, these industrial IoT platforms are adding the completing and contextualizing data, which it will be simplified to be reports and dashboards, which going to have some further explain how well the business is performing, how well these businesses get to be performing. And the thing was automation of an IoT. Next time, we revise this today. So yeah, coming to the automation of an IoT. So these industrial automation is of applications of various control systems. Simply gonna say that these of various mm, so yeah, this industrial automation is an application of various control systems. So it is for a managing of the processes. It is of a managing it is of a managing processes or through of a process like machinery industries, which it replaces the human involvement. So essentially, these it is used for a technology to perform the task that would be otherwise require of a human labor. So in placement of human labor, you want to deal with this. So sorry. So this is implemented for using some kind of technologies, which is programmable logic controls and industrial PCs, SC systems, and all this simply from IoT. So this is all technologies which it comes to automation of IoT as being get to be implemented. So under the PLC, which is programmable logic control. So it is an industrial computer controller which is being used for the operation of a control of a manufacturing processes and assembly lines and machines and robotic devices for any activities. So they require this kind of a of highly reliable where this erase the programming and process of a fault diagnosis. So these used to act as a physical interfaces in between the devices of a plant or a manufacturing floor of an operation which is my system. So it is used to act as a physical. It is these used to act as a physical interface in between the two device in between the devices where on a plant or a manufacture the floor and which is my system. So what is then the PL system basically? Sorry, PLC system. So basically, it is an industry computer control system where that continuously monitors the state of an input device to make decisions, which is used to be upon a custom programming to control the state of our output devices. So it is a control system. If in one word, I can even list as. So it has a continuously of a monitors and it states input devices which it makes the decisions which is based upon a custom program to control the state of our output to be devices. So these PLS has some kind of types which is namely a relay output, transistor output, and the three AC output, etc., which is suitable for AC and DC output devices even. So the software is used for Sony, which is like Mission Expert Basic, ProHedge, RS Logics, 5000, etc. So basic principle of this PLC is that is a process which it gives the information in our language, we say that outputs, right? So in that way, so it executes whatever the instruction of the program, instruction of the program, and it like after that execution of the processes, it delivers the result with an language which is called output. So with that based of a course provided information, they will return the some kind of logic what was required. So it operates that repeating loop once the user determines inputs and outputs. Okay, it repeats the loop after completion of the inputs and outputs. So example of this was Clean World PLC. And the advantage of these PLC is that it's flexible, reliability, and ease of the maintenance and going to be improved. This going to be improved safely. So, so with that, these fast response times and price of a control and scalability. So you're gonna have this as initial component of a modern industry or automation systems also. So why it is called PLC means that it is in a uh, designed to help the controlling of the manufacturing processes basically. So with these, they're going to have some automatic sector which it will be first industry to be deploy the PLCs into your operations. So the aim of this is to replace the hardware of a release and the times with programmable that where it fits the all the controllers. So the basic units of these PLC was the input modules or points and the central processing of central processing unit, which is basically we say that CPU and output modules and the programmable devices. The three main components of these was processor, power supplier, input output sections, input output sections. So the limitation of this PLC is that working of PLC is under the it works under the two things, which is it works under the two things, which is high temperature and the vibrations of the and high temperature and vibrations of vibration conditions. So these PLC turn on the power which is restored and may cause any accidents. The father of PLC was Dick Morley. He brought up this idea and introduced by also him only in the year of 1968. Next thing was the CADA. So it is the abbreviation of this is that supervisory control and the data occupation. So it is a computer-based system for gathering and analyzing the real-time data to monitor and to control the equipment, which it deals with the critical and time-sensitive materials or an event. So it is a system that aims to be a monitor or to control the field devices at your remote sites even. So yeah, it is all about that aims. It aims to be a monitor and to control the field devices at your remote sites only. So basically, it helps in a critical situation where to make the maintenance efficiency and by collecting and processing the real time data. Okay? So basically, CADA systems are helps to maintain the efficiency of controlling efficiency of collecting or processing of real time data, which it going to be a centralized open system which that monitors and control the over the say over the over the entire open area. So so basic work of this is to collecting and processing of a real time collecting and processing of a real time of a data processing of a real time of a data. We asked what is the difference between a PLC and SCADA is that. So the PLC is physical hardware and whereas SCADA is a software. So this means that PLC is gonna be get to be a pickup and physically of inspected, whereas CADA works upon a computer system to be comparable unto that any operating system like a Windows and etc. The main three things, so main four things of SCADA is that the first generation, which is the first generation, which is a monolithic, and second generation, which is distributed systems, and third generation, which is a networked systems, and the fourth generation, which is the web or IoT based systems. It is like that. Four types of an SCADA systems was first generation, which is a monolithic systems, and second generation, which is also described as the discrete systems. So third generation was an networked system, and the fourth generation was an webbed or an IoT based systems. So the functions of this is that the data authentication and the network of a data for communication, presentation and the control. It is used for operations which is a water and waste of water systems, electric generation, transmission, and digital transmission and digital systems and oil or gas systems and etc. So these going to include some water and wastewater system, electronic generation, transmission, distribution systems, oils and gas systems, etc. And it is a formation of an IoT itself. It had some kind of a features and functionality where it CEDA going to be ends. So it is used to control, CEDA was basically used to control, monitor, analyze the industrial devices and the processes, both hardware and software components. The main agenda of this is to collect the field information in which it will be transferred into the central computer facility and to display the information to your protectors and the actually of the actual. If you ask whether CEDA is analog or digital, the answer is analog because it's going to getting monitor and control the levels and temperature and pressures, flow rate and monitor speed, etc. And it is a sensor based only. It is a supervisory control and data authentication of a controlling of the processes of any real-time data, and also it has a communication systems of issue and also. It is not a programmable. Yes, guys. Yes, that's it for today.